Hello and welcome to this little project and code overview. So you might have seen in the previous video we're at a horror mansion and there's two companions as you walk around and they will use AI to speak to you. So let's hit play and give a little example. We're moving in first person and now I will click on this well or on this fountain, for instance. And
This place is really creepy. I've heard that there's some sort of monster that lives here.
she just made this up. This text is not defined anywhere in the code. She contacted GPT-3 by OpenAI and GPT-3 returned with an answer of what she needs to say, and then we're contacting the Google text-to-speech API service to get a voice audio, and then we let her say it and we move the lips as she does say it. So to explain the UX a little bit, when you click something, we will see who's the current conversation leader, and the conversation leader is the person who looks at us. You can see she looks at us. If I want to change this, I can focus on Brayton and he will look at me and she will look away. So now when I click on, let's say, the X, he will think
put that down. You're going to break something.
He will think of something to say. I can make her conversation leader again like this. So this is just that they don't talk over each other all the time, or so that I as a player can determine who I want to speak more at the moment, because these people have different personalities, which I will show you in a second. So, and another thing is when you focus the body as you're holding something and then you click, you will show the item to them and they will respond in some way. If you focus on their head, you will use the item on them, which also makes them react, but in a different way, especially when you're holding an X. And we have the hand, and if I click here, she will receive the item from me, like this.
I'm going to go explore the mansion. I'll be back soon.
And now she says something. And I mentioned that these have two different characteristics, and I will show you how that works. So let me hit pause for a second. So if I go to the tree of the project, you can see there's our person, the first person. We don't have a body because we're not visible at the moment. We have Jenny and we have Brayton. And they're both persons, but they're also speaking persons. Speaking person is basically a GPT-3 AI person. And I have a bunch of characteristics for her speech that I allow her to use. For example, descriptive, suggestive, arguing for, against, joking, and so on. And now what happens in the code is that we will randomly pick one of these. For example, we will pick joking. And then the prompt that we send to GPT-3 will be something along the lines of Jenny jokingly says. And then we ask GPT-3 to basically come up with a joke. Which, by the way, GPT-3 is not so great at. Suggestive would be, for example, we ask GPT-3 to complete the prompt. Jenny gives a suggestion on what to do, quote. So let's go into the code here to have a look. This is the speaking person. These are the allowed speech types that I just showed you. If I go to the speech type enumerator, you will see what I defined. For example, descriptive, commenting on what it sees. This is very basic. Predictive, arguing about what the protagonist might do next. Suggestive, making up things the protagonist could do next, and so on. I have a few more, like sharing statistics, sharing in-world numbers, like telling people this was the 25th punch so far. I don't use this at the moment, but it could be useful for a YouTuber kind of commenter, which is also a person which is using GPT-3. So let's go to the React function. For example, in the React function, we first check, do we have a preferred reply type defined by the causing event? Because in rare situations, I can say when this item is discovered or used, do something very specific, and this specific thing should be vocalized by the actor, basically. It shouldn't be ignored with a joke. For instance, in another house, I had a computer and there was a book with a password next to it, and the password was only visible when you turn on the lamp on the desk. And I didn't want this detail to be glossed over because it was not visualized. So I needed the commenter to explain what happened. So in that case, I triggered the event and I asked for a very specific, this one, an event descriptive speech type, commenting specifically and precisely on the event that just happened. Useful for triggering important prescribed plot points. I'm not using this in the current horror mansion that you're seeing here, but it's good to have in any case. So typically it's null, it's empty, so we don't have a preferred speech type. What happens then is somewhere here, I just take a random speech type. Note it's random just for what I allow the character to have. If I go to Brayton, for example, he's angry more often, he's arguing against more often in relation to what other things he's doing, and he's also joking. So he's kind of more aggressive and less helpful, or I tried to make him that way. And Jenny is kind of the main buddy. So now that I have a random type, I compile a lot of useful things for the prompt to be built. For instance, I get the item that is currently looked at, and this is in relation to the protagonist, which is our person. Our person is also in the scene, as you can see here. It's also a person. And every person, or at least the protagonist, has a perception class, and this has the function get component looked at, for example. So if I jump to the person perception class, you can see here I allow that person's head to basically cast a laser forward and tell me what it hits, and it will then return the component type T that I asked it to be an item in this case. If that component doesn't exist on the first collider inside, it will be null. In any case, it will be returned here. And then I have the item looked at, which is just in front of the person, or I have nothing at all. Just a quick aside, an item is everything in the scene that's like a prop, which I basically wanted to be seen and perceived by the actors. For example, let's click on this fountain. I named it water fountain, and you can see the item class here. And I could give it another title, but by default it will just take the title I typed here. So it will be literally a water fountain to the person observing it. The person observing it cannot see its shape, they cannot see where it's placed, they will just know, okay, there's a thing here called water fountain. So how does it see it? Well, we have a getPrompt function, which is basically saying, hey, give me all the text that I want to feed to GPT-3 for a completion to get back. And this text consists of many things. It consists of the items that are nearby. It consists of the item that is looked at by the protagonists. It consists of a list of the persons nearby. In this case, Jenny, Brayton, and John, which is the name of our person. I can change this if I want to. Our person could be basically anything, Susan. And let's have a look at the getPrompt function below. So we have getPrompt here. We start with an empty string, and then we kind of build that empty string. For example, we have a backstory courtesy of a class called EventLog, which I will take a look into later. And we ask it to get the backstory. The backstory could be null or empty, but in this case, let's see, go into the event log. We just said we're at the horror mansion. This is pretty much the whole story that we provide to the game, and the rest of the story is derived by looking at the items nearby. So let's say if there's a blood stain on the floor and there's an X and there's a fountain, well, it's already kind of a horror scenario, so the actors will kind of react to that because GPT-3 is smart and it sees the connections. So if we have a backstory, we add that to the main prompt. If we have a location defined, it will add that to the main prompt. Locations are basically invisible cubes or other collider or triggers, which I can just create zone switch. So for example, if I want specifically to have a zone for the living room or the entrance hall, then I could just create a square here, a cube here, size it so that it will not extend beyond these walls, and then the actors will know when they're inside this. I didn't actually make use of this in the horror mansion at all, because they can already guess where they are based on the items around them, at least insofar as I want them to reply. They don't need to know anything, they just need to know enough to make interesting or funny remarks. And then I get a list of the persons nearby. Again, I go into the person perception class and ask for a list of the persons nearby, or in this case, I already collected it above. So let's go into the person perception class. And we have, for example, get persons nearby, which is an array of the person class. We may exclude ourselves if we don't want that list to be containing us in that case. So we have a radius here, in this case 10 meters. And then it will create an overlap sphere, and it will collect all the person classes in that overlap sphere, if they're active and if they're not already added to the persons list in this case. And then we add that to a persons list, which we finally convert to an array. On a side note, I'm using GitHub Copilot to program, and it's super helpful. It's like an AI that completes your code. And I'm saying this in this case specifically because this idea of using a physics overlap sphere was actually given to me by GPT-3. I can show you how it does its thing. Let's remove this. And then for GPT-3 to get active, I just need to make a comment, or usually I do, and I say something like, find the component person nearby. And then I do this, and boom, it gives me all this kind of stuff. And it basically adds the code for me. In this case, it's probably already influenced by other stuff in this module, but I know it worked already when there was no such code here nearby. So this is probably more than it would normally do. But normally the code might be something like this. And then I just basically go inside and I tune it. I add more operators, more logic here. I might also reject what it says and then try something different. But basically, GitHub Copilot is super helpful in giving me like all this boilerplate code, or sometimes just to give me ideas what Unity can do, like physics overlap sphere. Maybe that was not in my mind when I did it. Maybe I would have wanted to shoot laser raycasts into different directions, and that would not have worked very well. So it's very useful, kind of like for me to explore the code. It's almost like Stack Overflow, but it's in your head or in your code. So we get the persons nearby, we go back to the prompt, and we continue build the prompt via the items that are here nearby, the following items, colon, space, and so on. The item looked at, we might give it a special role. If there's no current event, actually, and I will show you the event log later, if there's no current event, then maybe the item looked at is kind of a clue to what the protagonist or the first person player kind of wants to be informed about. So we're using that here. The protagonist is looking at something. We're getting the full title here. What's the full title? The full title is composed of the item name, but maybe the item is burning at the moment. So we want it to say like a burning candle, or maybe the item is wet or hot or freezing, which is also visualized with smoke or something in the game. Then we want the word hot to be included. And then we kind of add all the properties. And then we may also add a little bit of backstory to the item. Now, the backstory is interesting. So when a character comes up with a story for an item on the spot, like for example, maybe Jenny says this fountain is cursed, then we're dynamically adding that to the, let's go here, to the backstory of the item. And suddenly it will persist as being cursed just because basically Jenny improvised that backstory. We didn't provide it, but now that Jenny provided it, we want it to be respected in the future of the story. So we basically put is being cursed into the item brackets as kind of a side information. So now we have this huge prompt, and we finally get to the part where we ask for Jenny to say something. So Jenny, that's her name, can now maybe describe the scene if we want her to be descriptive, depending on what random speech type we figured out, or maybe we want her to explain, then she will explain it. Maybe she should describe the event, and then we get very specific and we ask GPT-3 to let Jenny describe what just happened, that is this specific event that just happened. So we kind of like redundantly paste it in again to bias GPT-3 to really react to this. And we have tells, tries to predict, supports, warns against protagonist name, warns against what protagonist name is about to do, and so on. Now, let's have a look at what such a prompt may look like. Let's hit play. And we go to the fountain. We click the fountain.
What is that?
And I go to the debug log, and here you can see the full prompt that we're sending. We're at the horror mansion. The following people are around. Brayton, Jenny, and John are protagonists. Nearby are the following items: an axe and a water fountain. John is looking at the water fountain. We were looking at it and clicking it. Jenny confused about what they're seeing. There's actually a bug. It should be Jenny is confused about what they're seeing. And then we end with a quote. And what does it mean? Well, we want GPT-3 to come back with a speech pattern. Let me just change Jenny is confused. So there should be an is here. And what does GPT-3 give us back? It gives us back, what is that? So this is now her speech. And why is it just ending like this? Because when we're calling OpenAI, when we're calling GPT-3, which is called somewhere around here, when we're calling GPT-3, we're asking it to stop when it gets a quote character. So we don't need more than what she says, because sometimes GPT-3 might just continue providing a story, and we don't need that at this moment, because our player will create the story. And then we're going into the speak animation for our person, for them to say this. And take a look at the bottom left here, and you can see
This place is creepy. Let's get out of here.
you can see everything being sort of event logged. John is looking at the water fountain. Jenny says, what is that? John is looking at the water fountain again. Jenny says, this place is creepy. Let's get out of here. John opened the door, and so on. Now watch it as I, let's say, pick up a goblet. There's a goblet here. Pick up the goblet.
What the hell is that thing?
Here it now says, John, just pick up the goblet. Jenny says, what the hell is that thing? So that's all courtesy of something I call the event log. Let's have a quick look at the event log. The event log contains a list of basically everything that happens in text form. So for example, let's go into the let's go into a class called our person interaction. For example, if our person is taking something, check taking, dropping. So if the dominant hand does not contain an item yet and there is an item being looked at, that is, the item looked at is not null, then, and that item has a takeable class, then the dominant hand will take that item that is being looked at. And what does that mean? Well, we have the take item class, and then we add to the event log, for example, let's go here. We add to the event log person first name, John, just picked up the goblet, and maybe it has a backstory. So this will now be added to the event log, courtesy of the hand taking it. And inside the event log, we have we have a static, so-called singleton class, and we have a self instance, which we now forward the add to. And inside this instance, we just add it to a list of events. We call this list type event log entry. If we go inside here, you can see the event log entry consists of a text, a possible preferred reply type, a time when it was added, originating person, like in this case, the protagonist took it, which might be interesting later, and we inform the event log entry that it's speech or not. And then we just compose this event log entry, add it to the events list, and then it can be referenced later by the speaking persons. They're basically, when they look to react, which happens every several seconds, and we are the conversation leader, then we ask the event log to get the newest event. In this case, please ignore what other people have said so they don't get into infinite circular discussions. And then we forward this to the reaction, which goes to GPT-3. Now in the event log, there's an interesting detail. We sum up everything that happened so far, every nth entry, in this case, every 12th entry. So after 12 things that happened, we summarize and then we clear the event log so that it doesn't get too long for the purpose of our story. We could just have it continue forever, but we don't want to feed GPT-3 a list of a million items, because then it would get very costly and it wouldn't work. So what is a summary? A summary is actually also contacting GPT-3. We are asking GPT-3 to give us a summary of the story above, which is just a concatenation of the event log texts. So GPT-3 is seeing a huge list of lines like John opened the treasure chest, John took a treasure, John goes there, John looks at this, John talks to Jenny, Jenny says this and this, and then we're asking the GPT-3 AI to give us a summary of the most important knowledge we gained in above story. So why don't we just ask it for a summary? Why do we ask for knowledge? Well, the idea is that as people are making up things about the world, for example, saying a witch cursed this fountain, we want this knowledge that we gain to be referenced and respected in future speech. So we don't want Jenny in half an hour to say, oh, this fountain, I built that and it's perfectly uncursed. No, we want her to say it's cursed by the witch. We want her to remember this. So we asked for the knowledge gained, and we're asking for a 2-sentence summary, which is sometimes respected, sometimes GPT-3 ignores it, but we intend to say, give us something very short. This also means that next time that we feed the summary into the future prompt, we don't need to worry about cost so much, because we don't have a story of several pages. We just have 2 sentences, which is very cheap. And another benefit is that it doesn't bias the prompt continuation too much towards the past story. Because in GPT-3, you need to be very careful if you send a backstory to not just focus on that. So we don't want Jenny, as we ask her about other items in the house, to always repeat, oh yeah, did you know the witch cursed this? And did you know about the fountain? And no, that would be very boring. We want her to sometimes reference the cursing of the fountain, let's say, or sometimes she should just respond freshly to something so that the story keeps continuing and it's not getting circular or repetitive. It's a bit like composing a meal, I suppose. So you add a bit of salt, but if you add too much salt, the resulting taste is not very good. So it's a 2-sentence summary. It's a bit of salt, okay? And then I can show you where we put the summary back here. So what we're doing here is we're saying if there's a chance of 15%, then please get the summary and feed it into the prompt again that we sent to GPT-3. So you're seeing we're pretty much ignoring the whole backstory most of the time, except every now and then the GPT-3 summary is respected again and goes into the story. Note, however, if the item being looked at or being exchanged is specifically one containing a backstory already, let's say I pick up the X and Jenny will say that X is cursed, then it will always be included. Because, I can show you, because we're saying get full title of the item. Let's say the X, and get full title, if we jump there, has a backstory that I showed you earlier. So we're not completely ignoring things. We're just not wanting the summary every time so that Jenny does not get too repetitive. Just a very quick aside, when people are talking, let me show you again. Let's let her comment on the X, for example.
I think that water fountain is cursed.
So she literally said the water fountain is cursed. I guess that's a trope in science fiction, and because GPT-3, or in fantasy, and because GPT-3 has a corpus of all the, well, pretty much all the world's knowledge and books, GPT-3 will associate horror with horror and water fountain with water fountain to be often cursed, I suppose. I guess because what other role should it serve if it's being talked about in a book next to a horror mansion? Okay, just to try to make her say something different for a change, I will start it up again though, because there are different roles a water fountain could play. So let's try her again to say something.
This place is weird. I've been getting weird vibes from it ever since we got here.
So now she's saying something different. She's not always saying it's cursed, but I suppose it's a likely trope. So anyway, I want to show you how the mouth speech is being done. For that, I go into the Jenny person character and I traverse her body, so to speak. And I'm at her head. The head is a rather simple class. And I have a head collider to check if she's being looked at specifically. And now I have a lip sync object. This is a third-party asset. It's called Now We're Talking. I just bought this from the asset store. And basically, I can give that class an audio file, in this case the one I get from Google Text-to-Speech, and I can make the class do something funny with her mouth that kind of fits the audio wave form. There's a bunch of things I can tune here. Lip speed, mouth resting. I can give it the eyebrows and the eyes so that she will automatically blink. Actually, in this case, I didn't do that. I should. So if I put the eyebrows here, you should see them start moving. I guess I forgot to do that. And now her eyes are starting to blink. Yeah, so that's the Now We're Talking class. And the audio itself, how does that work? Well, let's go into a class called Google Voice. And this class, with help from a Google Text-to-Speech plugin by Frost Weep Games, which is also something I bought from the asset store, and then adjusted. Okay, there's my Google Nest speaker just talking to me right now, distracting me. Hey Google, stop. Okay, I should probably unplug this. So in my room I have a light system where I can tell Google to turn on the light or to change the light color and stuff like that, or to play white noise. Anyway, so here's the speak class, and there I will call the text-to-speech service in the cloud, and I will ask it to synthesize the basically the GPT-3 continuation. And once it did that, I will play the clip, and once the clip is played, the Now We're Talking asset knows how to move the mouth. So I think we covered a lot of ground in this theme. Oh, by the way, a shout out to the asset makers called Synthi Studios. It's a third-party asset, and it's really terrific. They have packages like horror mansion, city characters, there's nightclubs, offices. And I bought these so that I can quickly do these prototypes without having to model all the 3D assets. And they also provide these great scenes, which I can basically use just like they are, and then just go inside and define the items as I need them. But I don't need to build the whole world for doing a prototype. If I wanted to release something as a game, I would probably have a slightly different concept and maybe a specific scene lookout, maybe specific models that I might do or that users could do in a sandbox universe, for example. But for this demo or prototype, it's really helpful to have something to get started with that looks good. Actually, while I'm here in the asset directory, I should probably give you a quick look at the structure. So I mainly divide into third-party assets, which I also don't commit to my repo at GitHub, because they're not by me. Then I have a global use folder. For example, the event log is literally like used by any class that wants to. So there's no, it just basically sits on top. And then there's objects. For example, we have a person which can follow other persons, which has a head, which has an idle animation, which has a health, for example. Health is something simple, like if I hit a person with an axe, it will basically change or injure using a negative amount the health, and then I can have that person die after a while. And so I compose a person of all these kind of things, like a health, a voice, a movement, a character controller. And it's very useful, this composition, because I don't want to inherit from a single person and then override the base class, because that can get very tricky if you want to compose a lot of different behaviors. So basically, I'm using object features instead of several layers of inheritance, and an object feature can then be on or off depending on what I want the person to be. So I have these objects here. I have a commenter, which you might have seen in another video. If I turn that commenter on, it's just basically a YouTuber sitting on the side, and that YouTuber will, let me try to focus on them. Where is he? Somewhere here. That YouTuber, he's sitting in the top level and he's just commenting on things he sees happening, and he's live streamed into the side of the window here. I didn't have that active for this demo. Let's disable them again. I have a camera which might follow the player. I have door system. I have environment sounds. The ground isn't used in this case. I have a hand, which you can see here. The hand may receive items. It may do different stuff like take items. Then I have the whole item class, which is kind of a simple base class. I don't do much here. It looks like I'm just using the highlightable class in turn to make it turn green and fade out the green again when it's being looked at or not being looked at. And then I have the object features collection. For example, an object might be climbable, it might be fillable, like a cup could be filled with coffee. It might be highlightable, it might be something to lie in, it might be something to sit in. In this case, I didn't work on that code yet, so sittable is just a property that I don't use that yet, but it could be a chair that is sittable. I have items which are takeable, which is important because not every item should be taken. And then I have properties like burning, freezing, hot, wet. Then I have usable scenarios, for example, a light switch on and off with a sound. I have open, closable. Let's go inside here quickly. For example, open closable has two rotation states, closed and open, which can be defined in Unity, and then I can just open and close it as it's needed. I have sawable, which means, for example, a wood table, which I want to apply a saw object on, and then it will get destroyed. I have the usable class, which is a generic base class that you can override, where you can, let's say I want to use a goblet with so if we go to the second floor, there's a bathtub with blood here. And where is it? So if I use the empty goblet here, maybe I want it to fill. So I can override this use with item in my goblet class or in my blood bathtub. So I go to use with item, and if the other item ID is a goblet, then I can do something specific here. I would probably then, like goblet fill with, I don't have this programmed yet, but I would do something like goblet fill with blood or something. So yeah, I didn't program that yet, but this would be how it works. And you can see the AI GitHub Copilot is trying to help me here. Goblet fill with blood, and then I could do all kinds of things later on with that goblet if that was my kind of adventure plot point. So yeah, that was a bird's view overview of how this is set up. I hope this was useful to you. You can ask questions in the comments and I will try to answer them. I might also share more code at GitHub. This is already on GitHub as a private project. Unfortunately, it wouldn't work without all the third parties which you need to license. So there's no mention on GitHub because I don't own that. You would need to license it. So that's why it's a bit more difficult to just put this fully on GitHub. But maybe there's a way to share more code. But maybe just this kind of concept and structure of the project gives you an idea how to lay out something for yourself, maybe something slightly different, maybe it inspires you to do something slightly different, but kind of cherry pick from this approach. So yeah, I hope it was helpful, hope you enjoy this, and see you in the next video.